Question 12 says to start with the prime number 41 and then successively add 2, 4, 6, 8, 10, 12, and so on to get the sequence of numbers here. And then it says all these numbers so far are prime. And in part A, it wants us to list the next 5 numbers in the sequence and check that they too are prime. So let's do that. I'm going to start with the last 2 numbers of the sequence that we've been given. So 131, the next one's 151, and then we want to know the next 5 numbers. So 1, 2, 3, 4, 5. And so I want to figure out what we've added in between these 2 numbers. Could just kind of count up, but that's a long sequence, so it's easier to do it this way, I think. So between 131 and 151, we've added 20. Okay, so that means that with our pattern of adding consecutive even numbers, for our next number, we're going to add 22, and then add 24, 26, 28, and 30. And then we can just fill these in. So 151 plus 22 is 173. 173 plus 24 is 197. 197 plus 26 is 223. 223 plus 28 is 251. 251 plus 30 is 281. And so I believe this might be different than the numbers that were given in the answer key for this homework set. And I think there might be just a small problem with the answer given where they accidentally shifted it, so I think they added 20 to 151. But if this is an answer you got, then that's great. This is actually the right answer. So let's check these numbers. 173, if we look at our chart of prime numbers, it is indeed prime. 197 is prime. 223, yep. 251, yep. And 281, yeah, we've got the pattern continuing. And these numbers, the next 5 numbers in the sequence, are also prime. So part B is asking us if this pattern forever lists prime numbers. So let's think about what we're doing in each case here. And it's a little bit hard to see, but what it ends up being is we're taking 41, and for the first number, to get to 43, we're taking 1 squared plus 1 and adding it to 41 to get 43. And then for the second number, we have 2 squared plus 2, and this gives us the next number of 47, and this pattern continues where for the next number, we add 3 squared plus 3 to give us 53. So you can see that the general form of this is we're taking 41 and we're adding n squared plus n to get our terms. And n is just increasing by 1 each time. So if we think about this, as we get higher and higher, eventually n will be equal to 40, and in this case what we get is 41 plus 40 squared plus 40. And if we look at this a little bit further, we can see that for the second 2 terms we can actually factor out a 40, and this will give us, so if we factor out 40 here, what we're left with is 40 plus 1 see if you multiply this 40 in, you'll get back to 40 squared plus 40. And if we simplify this a bit, we end up getting 40 times 41. You can see in this case we now have 41 as a factor of whatever this answer is. And we can actually work this out and check it. This answer ends up being 1,681. And if you divide that by 41, you can see that it is indeed not a prime number. So this pattern doesn't forever list prime numbers, because again we get up to a value of n where we now have 41, the prime number we've been adding to, as a factor.